Okay, we just made this cut here. That's our finish. There's what the company gave us on the bare plate. They cut it off there. It's not a bad cut. I took today and took the stainless steel project here of the strut here and took some of the blank cutouts that I ordered to make the blade material, and I was able to lay these on the table and lay out a cut line and trim these right to size. I mean, one, I was impressed. You know, I knew it was going to be able to cut it, and you know, I'm always prepared to do any grinding. You know, shit, when you're going by hand, you know, you have a lot of grind work. And today I actually didn't even get my grinder out. I was using the flapper wheels just to sand and roll the edge off. The plasma cuts are just extraordinary. You got this piece cut to go in here, and I've got the upper one here. And of course, we did the slug in the lathe the other day, and I left it undersize on here, so once we set it up and we do the full weld, we can come in here and bore it true for the bearing. And you know, in this our past experience, you can actually change the, you'll egg shape this about 1/16 of an inch. It'll grow one way and it'll come in the other way. But then once you get your completely fabbed, you go ahead and you set up in the machine, you bore through, and then that's 100% true. The base plate, of course, all we had to take was 1 inch off of that, and that was just a straight line. But to cut these materials here, we went ahead and this is where I really got impressed, was that 1/2 inch stainless steel, and to cut out those letters. Letters, I'm finding, are a very good tool to quickly put something in there and really give a good run test. Okay, we've taken 4 pieces of 4-inch flat bar, 1/4 inch thick, and tack welded them to the table with 2 tacks in each one, just so that we hold a parallel position for each of these blades. And we're compensating for the thickness. This is about 1/4 inch, and the material we're using is 5/16. So we got to kind of coordinate what the center line is, and we're going to go ahead and fabricate a cradle that will support this round at each end of it, and then we'll tack that into position. We're going to cut those out on the plasma cutter, or at least we're going to try to get some of this right to the size. After we do that, then we're going to go ahead and create the underside of the palm on flat stock and slide it in position and tack weld it to there for a keeper to support that plate. Now, let's go ahead, and we've got these set up on the screen. We're ready to cut these. Okay, our pieces have cooled down, and they're just going to slip right in there right now. They're a little bit under pressure now. You can see just a little bit of lifting on this right here. So that's what they're figured out, so that when we put the 5/16 in there, I'm going to put a little angle back here, and we can hold that angle flat and eyeball it side to side parallel, and we're going to tack it. Okay, we're just holding these in place to tack them. Okay, we can put a stop here for our length. And a stop here for our length. Okay, let's see how well we did. We'll pop out this one. We pop in the slug. Nice and tight. Alright. We pop in the foot. Alright. We'll put a clamp on here. Alright. Now fix it. And there we go. Okay, I set up the stainless steel palm in the flat table mill here. Made two aluminum. Well, actually, I didn't. I just cut a piece of scrap in half, half-inch aluminum, and supporting up off the table, even both sides, and then toe clamp it in the center. And I cleaned my center line with my pointer here, and I'm drilling these holes and countersinking them 90 degrees to the table, because the inside of the hull of the vessel is 90 degrees to the keel, and that's how he wants the bolts to run. So sometimes you have a combination where you want to follow the angle of the plate, and sometimes you got to be straight. This is a straight set here. We feed this down gently because it is an interrupted cut. It's basically wanting to cut on one side and not the other side, and we want it to follow the hole so that the countersink of the bolt is pretty close to the hole. Okay, we've got this out of the welding position. It's cooled down. We've already gone in and straightened every bit of pole. That's the weld pulled here or there and took away the perfect alignment we had it set, but we know we can put it back there because it just pulled it over. So we're going to compensate the weld pull, and we did it in stages. We actually, everything went by this palm, each side, equal distance, side to side, and measured our relationships, you know, like here, and same thing here, both sides. So we straightened this weld first. After that, then this underside weld here, we had to twist the shell itself to get it in line, and it from side to side here, same thing on the other side. After that, then we went for the long run up here, and so we got that alignment there. The bore, just for your information, this is like 520, and we got like 480 there. So we got 40 thousandths. So it actually spread it this way, squatted it this way. It's the way that weld works on a bore like that. And we got plenty of meat in there. In fact, we're going to be taking this into the lathe now and setting up for a line bore. The last measurement that we were concerned with was from the table up to the edge here, there to the edge here. We're about a 1/4 inch low. And that's because this weld around the base here has flattened out our dish. And we've already checked the angles and we got that. We're going to be setting that back in the press and deepening that dish. So that's where we're at now. We're moving on.